Now we will see the general facts about list interface in collection framework. Okay, as you can observe here, array list is implementing list interface, linked list is implementing list interface, and vector is implementing list interface. Now you can observe the link between linked list and queue. So what we can understand here, the linked list is both list type and queue type. Okay, linked list is both list type and queue type. Okay, if the requirement is a frequent reading operation, array list is the best choice. Why? Because array list, it is internally using the concept of arrays is index based. Now if our requirement is a frequent reading operation, array list is the best choice. If the requirement is a frequent reading operation, linked list is not recommended. Why? Because the elements can be anywhere. The linked list, in case of linked list, the elements can be anywhere in the memory, but there will be a reference to the elements, but we cannot know where, like element will be in the memory. It will be scattered in the memory in case of linked list. So it is not recommended at all for a reading operation. Then vector class is a synchronized. Okay, vector class is a synchronized. So as we know, if it is synchronized, performance will be low. Performance will be low. And you know if in case of a multi-threaded environment, we can use the vector. If in case of multi-threaded environment, we can use the vector. That is the only major difference between array list and vector. Vector is synchronized and array list is not synchronized. Okay, the next point, if we want to insert the element in between two elements, if that is our frequent operation, array list, it is the worst choice. It is not recommended because a lot of shifting needs to be done internally. A lot of shifting needs to be done internally. Consider this one. Okay, here I wanted to insert 0 in between 1 and 2. Okay, I wanted to insert 0 in between 1 and 2. I wanted to insert 0 in between 1 and 2. So a lot of shifting operation needs to be done here. you know um, the previous element 2 will be moving to this location, and this 3 will be moving to the this location, and this element moving to the next location, like that. There will be a new space will be created. Okay, then that element will be kept. So here, as you can see, shifting operation is going on. Shifting, if we want to insert an element in between two elements, so there will be a there will be memory will be allocated, but a lot of shifting needs to be done. So that is why it is causing the performance issue. So but it is not the case in case of linked list. Why? Because you know in linked list, every element will be having head and tail, head and tail, head and tail, head and tail references. Now I wanted to insert 2 in between 1 and 3. I wanted to insert 2 element. Okay, I wanted to insert number 2 in between 1 and three element. Now simple, you know, the this reference will be deleted. Earlier it will be like this will be pointing to this, and this will be pointing to this, like, this tail will be pointing to head, and this tail will be pointing to head of this element. Now these links will be removed and assigned to new element, the element we wanted to insert in between. Okay, so it is very easy. So if it is in case like we want to insert element in between elements, if that is our frequent operation, you know, array list is the worst choice and linked list is the best choice. And what about this element that we have removed the references? It is automatically eligible for garbage collection. Thank you.